So looking at this problem here, we have equilateral triangles, and we shrink them down, and we rotate them. We shrink them down by a factor of 5, and we rotate them 60 degrees. And so this triangle here, it rotates around and ends up upside down here in half the size. And so what I have to do is I'm asked to find the perimeter of T0 to T3. This is T1, T2, and T3. So basically I want to find the perimeter of this shape. Well, we recognize that being equilateral, that all the sides are the same. So this is a distance of 2. This is 2 and 2. And if it's going to be shrunk in half, that means this is 1. So I get 2 plus 2 plus 1 plus 1 more. Oh, sorry, plus 1 plus 1 more plus a half, because it's half of that. Well, this also is 1/2. This is going to be half of a half, which is a quarter. That's also going to be the quarter. And then the last little bit is also, this here is a quarter. So these last three all end up being a quarter. And so plus quarter. And so when I add all of those values up, it's just 7.75 is what the sum of T0 all the way to T3, and it is my so this is the perimeter from T0 to T3. So now when we explain why the maximum perimeter is reached when I hit T5, well, let's consider what happens here. So my next triangle is going to be a little tiny triangle here, that's T4. And then the T5 is going to be another little triangle that's rotated around, and it's here. And then T6 ends up being inside. And then they keep going inside, and so the perimeter is just on the outside of this. So once we hit T5, there's no more perimeter to be at because it goes inside the triangles. So that is why the maximum perimeter is reached once it is T5. And I want to find this value. Well, at this point, I know up to T3 is 7.75. Okay, and so from this, let's take all these values here. This is 7.75. If I'm going to do it, I have to recognize that I added this last one, which is a quarter, which is too much. I'm going to take that 1/4 off and add in 1/8 plus 1/8. So this is 1/8 plus another 1/8. Plus a 1/16, and we know there's 2 of them when we look at the pattern. And I think that's going to be it. Let's just double check. So I know that this is 1/4. This is an 1/8, the 1/8, and the 1/8. This is the 16th and the 16th, and then we are finished. And so when we add all these together, and we have to recognize that this last 2 has to be subtracted as well. It's not a full 2, it's going to be subtracted away of a 1/16 as well. And when we add up all these values, we end up with a value, and I'm just looking at the answer key here, 7.8125 is the maximum perimeter of this shape. Okay, so moving on to C part. E is the enlargement matrix, and so that's going to be 1/2, 0, 0, 1/2, because we know it's been enlarged by a factor of a half. And R is the rotation matrix, and it says by clockwise 60 degrees. So looking at my formula booklet, I know that it's going to be cosine 60 positive sine of 60, negative sine of 60, and cosine of 60. And if I simplify this, I get 1/2 root 3 over 2, a negative root 3 over 2, or 1/2. If you do these in decimals, which is totally fine, you will get these decimals either way. Okay, so now we have E and R. Oh, I guess this is D part here. So here's E. My determinant of E is simply going to be, if I go A, these two values multiplied, so that's 1/4, minus those multiplied, so my determinant is equal to 0.25. And those are the values here. So now, find the area of T0. Well, T0 we know is the equilateral triangle with a side length of 2. Now, if I want to find the area of T0, well, if I have my triangle, here's 2, and here's 60 degrees. The easiest thing to do is do 1/2 2 times 2 sine of 60. This is the 1/2 AB sine C formula for area of triangles that we learned last year. And so those cancel. This is root 3 over 2, so it's 2 times root 3 over 2, which is square root 3. Or if I have it as a decimal, I don't have it written, but you could do it as a decimal or exact value. So each time I know my area, and the original one is that. So if I want to find the area of T1, it's going to be the determinant times root 3. So it's going to be this times root 3. If I want T2, well, it's going to be this one. Well, my determinant times this area, and so on and so forth. Okay? Because we know there's a formula that says the image area is equal to the determinant times the original area. All right, so now it says, hence find the total area covered from T0 to T5. Well, if I'm going to go T0 to T5, well, that means that there are, each area, I start off with T0, which is here, each area gets multiplied by 1/4. This is a geometric series. And so if I want to find the total area, it's going to be the sum of all these values, and that's U1, 1 minus r to the n over 1 minus r. And so this is just simply going to be my sum of all 5 of them from 0 to 5. U1 is square root 3, because this is the first term. 1 minus, well, it's a 1/4 is r. And there's going to go from here to here. That means there's going to be 6 multiplications of 1/4 in total over 1 minus 1/4. And if I just do this, I end up with 2.31 as my total area of the figure. Okay, so moving along here. Okay, so now D part says write down the matrix R. Well, we've already got that conveniently. Here's R, I've done that. So find ER. Well, ER is going to be 1/2, 0, 0, 1/2 times 0.5.866 negative 0.866 times 0.5. And we can just put this into our calculator. And we should get 0.25, 0.433, negative 0.433, and 0.25 is equal to ER. Okay. And then finally it says, use your GDC to find the coordinates of all three vertices in T8. Well, if we think about our T1, or T0 rather, we have each of these values here. And so if I would take my first vertex, 0, 0, if I multiply that times ER, right, that times ER, I will get, like T1 vertex. If I want to get T2 vertex, and granted 0, 0, so it's not the best example, but I could also, let's use -2. Let's use the -2, the -2, 0. And so if we multiply that, then we're going to end up with where this one goes, which should be here, and so on. To get T2, well, I'm going to take ER times T1. Well, I know that T1 is simply ER times -2, 0. And so it's going to be ER squared times -2, 0. So the question is asking for T8. So if I want T8, I'm simply going to take ER, raise it to the power of 8, times -2, 0. But I'm also going to go times 0, 0. And the last one up here is this height here. To find this height is -1. Well, I know that this is 1, this is 2, so this height is square root 3 by Pythagorean theorem. So the last T8 value, if I go over -1, I go up square root 3. If I multiply this all out, I end up with 0.00391, 0.007810. Oh, I have these two backwards. And I get 0.00677 and 0. And I have to make sure that I switch these two around. So this was 0, and this was 0.00781. And so that's what the vertices for T8 will be, using the idea that I can multiply ER 8 times each of the vertices.